Hi friends, today we are going to discuss more about Octet Rule. Okay, so you know that what is Octet Rule? So if we are starting with octet, the number is 8. Okay, so if any atom which is gain or lose or share electrons to fulfill their valency cell to gain 8 electrons, that is a basic understanding of Octet Rule. Now, atoms generally try to gain 8 electrons in their outermost shell. Okay, an outermost shell, which is also known as valence shell. So, according to octet rule, every atom they try to gain 8 electrons in their outermost shell. Okay, and this is octet rule. Now, how they can do this thing? Okay, how they are going to get 8 electrons in their outermost shell? If they are having less electron, so they are going to share the electron by forming covalent bond. If they are having more electrons, they are going to transfer the electrons. So they can gain gain electrons, they can lose electrons, they can share electrons. Gaining or losing will lead to ionic bonds, we know very well, which we already discussed. Sharing of electron leads to covalent bond. So I'm discussing about atoms which do not have octet in their outermost shell or do not have 8 electrons in the outermost shell, that is valency shell. So they are going to gain 1 electron, 2 electron as per their need. So they can gain electron to achieve octet. They can lose electron to achieve octet. They can share electron to achieve octet. So here you can say that atom A or atom 1, they are having 1 electron in the outermost shell. So it is easy for them to donate one rather than gaining 7 electrons. So they are going to donate 1 electron to the B atom, which is having 7 electron in the outermost shell. So both of them, after losing 1 electron, A will gain octet. You can see here 8 electrons are there. And B, after gaining 1 electron, will become 8 electrons. So this ionic species lead to the form of ionic compound where A and B are having octet in their outermost shell. Similarly, A and B, instead of transferring electron, here we can see that electrons are transferred, but in this case, electrons are shared. If electrons are shared between A and B, that 1 electron which was there, you can see atom 1 is having 7 electron in the outermost shell, atom B is also having 7 electron in the outermost shell. So they are generally sharing 1 electron each, and they are forming a single bond, which is known as covalent bond, and they are gaining in such a way octet. So there are 3 ways by which any atom can gain octet in their outermost valency shell. So first thing, they can gain electron, they can lose electron, they can transfer electron. Okay, let's see some more examples of octet rule. So this is just a cartoon displaying how octet can be achieved. So you can see this car has capacity of 8 electrons or 8 person. So once these 8 persons are there, they are not going to take any other electron or any other person. They are going to leave 1 electron extra. Once there is a space for 1 electron, that electron can enter inside so that the octet will be full. So once the octet is full, they are not going to gain extra electron. Okay. If octet is not empty, they are going to get 1 electron, 2 electrons per their need to complete the octet. So this is the basic representation showing octet rule. Here you can see a visualization which is showing how the sodium and chloride ion is formed by transfer of electron from sodium to chlorine. Here you can say that sodium has 1 electron in the outermost. By energy, the electron is transferred in the chlorine outermost cell. Chlorine get 8 electron in the outermost cell, as well as sodium also get, and they result in the formation of sodium chloride ionic compound, where the sodium forms the cation and chloride forms the anion. Okay. These are other examples where you can say the central atom of each. Here, the carbon is the central atom, and it forms single bond with every hydrogen surrounded. So you can say that each hydrogen is giving one electron, which is pairing with the carbon's one electron and forming a single bond, single bond, single bond. So there are four carbon hydrogens covalent bonds, single covalent bonds, which leads to the formation of complete octet at the center hydrogen. And hydrogen only need two electrons to complete their octet. We know that. So they are duet rule. They don't form octet rule. We are going to read it in the upcoming slides. So this way, copper gain the octet completely. Here 8 electron because four they have and the one electron from the each hydrogen we get. So it is a sharing of electron and that's why they get 8 electron as well as covalent bonding system. Bromine, 7 electron in the outermost shell, same these bromine. So they are going to share 1 electron each and form a single covalent bond and gain octet rule. Okay, 8 electron in the outermost shell. Similarly, the oxygen, which is having 6 electron in the outermost valency shell. So there they are gaining 1 electron from the hydrogen and they form one single covalent bond with each of the hydrogen and result in the formation of complete octet. So these are few examples where octet rules are followed. Okay. Let's see some other example. This is carbon dioxide. You can see that carbon is having two covalent bonds with each of the hydrogen atoms, where the oxygen is having 6 valence electrons. So it is sharing two of electron with the carbon 2 electron. So they form two covalent bond on both the sides and they result in the complete octet of the oxygen as well as carbon also. So here oxygen is also having 8 electron. Carbon is also 4 here, 8 electron. Oxygen again is having 4 this and 4 this. So 8 electron is there. So here also octet rule is followed. Okay. Let's see what is octet rule. We already told whenever atoms are most stable, they are in having 8 electrons in the outermost shell. So they try to do this by sharing, gaining, losing of electrons. So they try to fill their outermost shell with 8 electrons, which is the basic understanding of octet rule. So we can say that 8 electrons in the valency shell leads to the octet rule. Okay. So they can participate in chemical bonding so that they can attain the octet, whether it is a ionic bonding or it is a covalent bonding. So these octet rule are generally applicable to the main group elements. Okay. Then we can say that these groups are also applicable to the halogens, halides, chloride, bromide, iodide, oxygen, nitrogen, and carbon covalent bonding as well as ionic bonding. You can see they follow the octet rule. But in general, there are some exceptions. S block elements, P block elements, they are also involved in the octet rule formation. But except hydrogen, as we discussed, they form the duet rule. Okay. Duet rule, where two hydrogens are needed. Similarly, helium also, that is already having 2 electrons in the outermost shell. Lithium also, they are not following the octet rule. Okay. Now, what are the exceptions? Not all the elements and compounds follow the octet rule. They have some exceptions. As I already discussed about hydrogen, helium, lithium, there are some other portion also we are going to discuss, like free radicals. Any atom, any ion, okay, atom or molecule containing an unpaired electron, unpaired valence electron is called a free radical. Or radicals where atom, ion, or molecules, they contains any unpaired electron, which lead to the formation of radical. And these radicals never going to obey the octet rule because they are odd numbers. So they are unstable as well as, so they try to dimerize so that they can form a more stable species. So dimerization leads to the stability of the radicals and free radicals are not following the octet rule. Let's see some other examples. Like we can say some of the elements having only one cell, so they can accumulate 2 electrons, like lithium, helium, hydrogen. So they follow duet rule. So instead of the octet rule, these elements form duet rule. They follow duet rule. So for example, lithium can lose 1 electron and have a stable configuration of 2 because lithium is having atomic number of 3. So they are going to lose 1 electron and can have 2 electron in the outermost shell. So they also follow duet rule. Okay. Now let's go for some D block elements where they have you can say that different configuration which represents their stability. They don't follow the octet rule because they have presence of a d orbital. So the transition elements, the elements which are present in the d block, these transitions do not obey octet rule, and the valency shell of these elements can hold 18 electrons rule. So they have separate rule which is known as 18 electron rule. We are going to study in higher class these things. Okay. So now one last topic we are going to discuss about the octet rule is these are also systems which you are not going to follow the octet rule. So these terms are called expanded octet, where the atoms or the elements at the center is going to have more electrons than 8. They are going to have more than 8 electrons in the center. So here some example is there that is called PCl5. So we know that phosphorus has having 5 valence electrons in the outermost shell. So you can see 1, 2, 3, 4, and 5. These 5 bonds are there where one electrons are followed shared with each chlorine. So chlorine is having 7 electrons, so it can gain octet by pairing with 1 electron of the phosphorus. So each chlorine pair with 1 electron of phosphorus and lead to the formation of stable octet. Here also you can see chlorine is giving 1 electron from chlorine and 1 electron from phosphorus. Similarly, each chlorine is having stable octet. Okay. But in case of phosphorus, 5 valence electrons phosphorus has, valence electron plus 5 electrons from the chlorine. Okay. Total 10 electrons are there at the center atom. So phosphorus is having 10 electrons, which is violation of the octet rule. And that's why this phenomena is known as hypervalency, where phosphorus is having 10 electron. Okay. Similarly, you can see the sulfur. Sulfur is having 6 electron in the outermost valency shell, and each electron is paired with the uh, fluorine outermost electron. That is, sorry, for fluorine is giving 1 electron and forming complete octet with the each of the sulfur electrons outer valency electrons. So here fluorine is forming stable octet by sharing 1 electron with the sulfur's 1 electron. So fluorine is getting octet because fluorine has 7 electrons, so they can gain 1 electron to complete their octet. Instead of sulfur, which is having 6 valence electron, they gain 6 more electron from the fluorine. So sulfur is going to have 6 plus 6, 12 electron, which is again the violation of octet rule. And it is the term also known as the expanded octet, which is also known as hypervalency. That's all from the octet rule. Thank you, friends.